In this video, I want to show you some more advanced techniques for partial fraction decomposition. The first, only 3 questions, 3 different sort of types. So here's one that's different from the last video in that there are 3 factors in the denominator, 3 linear factors. So the way we do that is we're going to end up with an A and a B and a C, x plus 2, x minus 2, x minus 1. The approach is the same. Multiply both sides by this denominator. And when you multiply all 3 of these things by this term, the x plus 2 cancels out, and the x minus 2 and x minus 1 are there with the A. If I multiply it by this term, the x minus 2's cancel out, and you get b x plus 2, x minus 1. And the last term, the x minus 1 cancels out, but the other 2 are still there, x minus 2, x plus 2. So there's a lot of x's in here, but the convenient value method works really well, because if you let x equals negative 2, what happens is that this term, that x plus 2 becomes 0. This x plus 2 also becomes 0. So the b and c terms just disappear. And all that's left is 2 times negative 2 squared is 8. Minus 5 times negative 2 is plus 10, plus 18. And the a, if you put the negative 2 into this and this, negative 2 minus 1 is negative 3. Negative 2 minus 2 is negative 4. That becomes 12a. Or 36 equals 12a, or a equals 3, which is 1/3 of the answer. If instead you want to keep the b term, you would let x equal positive 2. And then this 2x squared minus 5x, that thing would turn into 8 minus 10 plus 18. And when you put 2 in here, you get 2 minus 1 is 1. Oops. Putting 2 in is not the right thing for making that a disappear. Sorry, I'm not trying to make the a disappear. I'm trying to keep the b term. So on the left side, I get 8 minus 10 plus 18. On the right, the a and c disappears, and I get 2 plus 2 is 4 times 1, so 4b. And I get 16 equals 4b, or b equals 4. And then finally, to keep the c term, I'm going to plug 1 in as a convenient value, and I'll get 2 minus 5 is negative 3 plus 18 is 15. And putting 1 in for the sorry, I'm keeping the c term. C times x minus 2 times x plus 2. 1 minus 2 is negative 1. 1 plus 2 is 3. So negative 3c, and c equals negative 5. And that's our first type. So the answer is 3, 4. You could put the minus there. Okay, so that's 3 linear terms. Okay, the next type that I want to show you is something like this, where the denominator has a linear term but has it raised to a power. When that happens, see, we want 2 things whose common denominator is x plus 4 squared, and the trick to it is to call one of them x plus 4 and the other one x plus 4 squared. If they were both x plus 4, then the common denominator would be x plus 4. So this is the way. Now there's a chance, like a could become 0. Not this time, because then you would have you wouldn't have this 3x here, but this is how we set this kind up. And if it was a cubed, you'd have another plus c x plus 4 cubed, but there isn't in this case. Just like before, multiply everything through by x plus 4 squared, get 3x plus 17 equals a times x plus 4 plus b. Now, we could do convenient values method by plugging x equals -4 in. We get -12 plus 15 plus 17, sorry, equals b, or 5 equals b. That's half our answer. But we can't plug anything in to make the b disappear because there's no expression next to the b. So instead, I'm going to switch over to the other method, distribute the a through, and now I can equate the coefficients, and the easiest one is the a and the 3 have to be equated because they're both coefficients of the x, so a equals 3. You could have also equated the 4a plus b with 17, and you would have also eventually gotten a equals 3. And that's the second type. Now the third type is the most complicated. Okay, here's the story with the third type. The denominator, we have a linear term, so that's going to go like that. Now this term here, the thing about this term is that this one is known as an irreducible quadratic, meaning that not only can it not factor the way like x squared minus 9 could be factored into x minus 3, x plus 3, and not even like x squared minus 5, which, though it doesn't factor nicely, could be at least solved like with quadratic formula or other methods. But this x squared plus 9 has imaginary roots, so we call that an irreducible quadratic. If you want, you could work out the discriminant as b squared minus 4ac, which is 0 squared minus 4 times 1 times 9. It's less than 0. That's what's meant by irreducible quadratic. So we can't do anything with that. We're not allowed to use imaginary numbers in our factoring for this. Now, what goes in the numerator? Well, it's not just a b, but instead, see, the trick is to the numerator. It's a constant when the denominator is a linear. But when the denominator is a quadratic, it's not a constant anymore, but it's a linear. It's always, as long as the degree of the numerator has to be less than the degree of the denominator, so we call it bx plus c. And this is going to get kind of hard. Here's the way we continue now. We multiply everything by this denominator, so we get 7x squared minus 9x plus 29 equals a times x squared plus 9 plus, complicated here, the bx plus c, good idea to put that in parentheses, times x minus 2. Now, as far as convenient values go, the only convenient value is x equals 2. That would make this thing into 0. And we would end up with, the right side would be a times 2 squared plus 9, which is 13a. And the left side would be 28 minus 18, which is 10, plus 29 is 39. And a would be 3. So we can get one of the answers pretty easily with convenient values. But for the... So I'm going to actually multiply through and see what happens if I go to equate the coefficients. This is ax squared plus 9a. This thing, this is why we need these parentheses here, because when you do FOIL, you get bx squared minus 2bx plus cx minus 2c. And when I combine the like terms, I get a plus b x squared plus, I'll just say c minus 2b x, and then plus 9a minus 2c. So the a plus b is kind of like the 7, and with that, because we already know that a is 3, so 3 plus b equals 7 and b equals 4, which is we have the 3, now we have the 4. Now for the c, I could use either of these because I know what a and b both are. I'm going to use this 9a minus 2c. So 9a, a is 3, so 27 minus 2c equals the constant term, which is 29. And we get 2c equals minus 2, or c equals -1. And that's why the answer to this question is 3 over x minus 2 plus 4x minus 1 over x squared plus 9.